Hey, hello, and welcome to the show. It is me, John Park, and I made my intro song shorter than I thought, so I was over there turning lights on and stuff when I heard the song ending. Whoops. Thanks for joining me. Look, here we are. It's Thursday. It is 1 o'clock-ish here on the West Coast. Hope you're doing well wherever you are. And I want to thank you so much for joining me. Thanks for jumping into the chats. We have YouTube chat over here. I don't think I have that one shared. I'll set that up for next week. But yeah, YouTube over there, Dave Odessa and Beatrice Abdelhagen, Cedar Grove Studios. Hello. Hey, Peter Huseman 3956. Good afternoon to you. We do have the Discord chat. There it is. And if you want to join that Discord chat, you can just look for adafru.it/Discord. It's our URL shortened version of the invite to get to our Discord server. Once you're there, plenty of channels to choose from. The one that's active during live streams usually that you want to check out is that live broadcast chat channel over there. Who's in the chat here today? Let's see. This was C. Grover and Paul Cutler and VP Tech Ops, Thin Man, Johnny Bergdahl. Hello. Getting ready for your weekend. Excellent. Good to hear. So let's Let me give you an idea. Let me orient you. Let's talk about what we're going to do today. I've got a coupon code for you. I've got we'll do a little announcement about the last sale week from this month, which has been this month of sales weeks. I've got a recap of the product pick of the week show, a new CircuitPython Parsec. We'll talk about the upcoming Learn Guide for the ES Spectre port that I've done. We've covered that. I think we're just about done with it. I just wanted to kind of wrap up showing it, and then I'll finish up writing the guide. And then I'm kicking off a new project, so we'll talk about that a little bit. I also have related to the coupon code, I have a new gear report kind of thing, freshly announced. I just ordered mine. I'll probably show it off once I get it in here. What could it be? Wait and see. Is that it? I think that's what's going on. So let's start off with a coupon code. If you want to save some money in the Adafruit store, go to adafruit.com. That's the store right there. Use that coupon code. The coupon code today is computer. So use that. Type that in the coupon code slot. You're going to get 10% off anything you order that's physical goods that we can ship to you. So it won't work on gift certificates, software, or subscriptions, but it is terrific for things that we'll put in an envelope or a bag or a pouch or a box or a trunk or a crate and ship to you wherever you may be that we can ship. So go and check out the shop. There's some nifty looking new things in there. Let's actually take a little journey into the shop for a moment. So there it is, adafruit.com. You can see here in this new products section, there are a few Stemma QT boards. There's this 24-bit ADC 4-channel analog digital converter. There's a new 3D Hall effect magnetometer. If we click on view all new products, upcoming, so you can't order that yet, is a new Vicnol 4030 proximity and lux sensor. I like those. There's a couple of different flavors of the Hall effect magnetometer there, depending on the gauze rating that you need for your project. This is looking neat. Oh, there's one left. If you want to get one of those Pymaroni Inventor 203050W Pico 2W A-board PIM 733, whoo, that's a mouthful. Inventor boards, get it, grab it. You'll save half. And that is a breakout board for the Pico that has a whole bunch of added functionality. And a few other neat looking Stemma QT boards that have been released or updated or refreshed. I think we're mostly out of these inky Raspberry Pi boards, e-ink boards. But that's just scratching the surface. If you go to the featured products, you'll see some others that we have listed here. And then you can always go to categories under, let's see, I've got to make my, there we go, all categories right here. Look for stuff that you want. Save a bunch of money on it using that coupon code right there. That's the coupon code for today. It is computer. 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 Next up, that's not all the savings. We've also got this final sales week of the sales month, and this is clearance items. So we have this category, clearance. It is at category 10025. I'll head over there in a second. But this is stuff that we have marked off anywhere from 40 to 60%. So a bigger savings in the last couple of weeks, I think, have been up to 50%. Here we have some items that are 60% off. There's one that I swear is even more than that. I'll show it to you. I think it's a good pick if you're into keyboards and stuff. But this has been the month of clearance weeks, or month of sales weeks, I should say. It's the final one, so you have till the end of the week. I don't know exactly how we define that. Is that Saturday at midnight East Coast time? Possibly. But if you want to jump on something now, I would recommend it before it sells out. And if you head on over to Adafruit and do categories /1025. This is where we have collected the clearance sale items. So some of these you'll have seen from previous weeks. Some of these you have not. For example, surgical masks, other PTE gear, this face shield with glasses frame. Here's a $21 Sony Presence 5 megapixel camera board. These are great. These Pi cowbells for Pico with the breakouts, screw terminal breakouts. Good price on that. Fluorescent pigment. Perhaps that's what you need. I was gonna point out, oh, these are nice too, these snap-on enclosures for the Trinkies. I was gonna point out some of this keyboard stuff. Here I think is the biggest bargain. Do we still have it? It is the aluminum keyboard enclosure. Look at all this clearance stuff. Bunch of NeoPixels. So these have sort of been grouped together with the previous sales. Oh, we've entered the keyboard stuff dimension. Get ready. Keycaps, sure. Big gumball size keycaps. I love those. Keyboard feet. These are really good feet. I put these on different projects. I put them on my arcade fight stick project there. And there it is. Look at that. Lavender. Not the lavender one, the purple. Purple anodized aluminum 60% GH60 keyboard shell. Okay, yeah, it is probably 60% off. 30 bucks instead of 75 bucks if you want to build a really premium 60% keyboard. You could use a KB2040 to drive it, be the brains. There are a few different PCBs out there in the world that use matrix, column, and row, diode matrix, column, and row that would fit this. This is a fairly standard keyboard shell size, this GH60. You can get the matching top plate for it too, this keyboard plate here. So those are some things that are on deep, deep discounts. Scroll through there, see if there's something you like, throw it in the cart, and you will get your clearance price on that. All right, let me just see if I can pause some of that. Bing. Oh, where did they put focus? There it is. Focus. Let's see if that works. So clearance stuff this week only. All right, moving that out of the way. Next up, we've got my Tuesday show, product pick of the week show. If you want to tune in and save money during the live stream only, then show up for this every Tuesday, 1 o'clock Eastern, 4 o'clock Eastern, 1 o'clock Pacific. This was this week's product pick, the Flora V3. Here's a little recap. that are ADCs, where you can use things like potentiometers and strain sensors, flex sensors. There you can see we've got just NeoPixel LEDs lit, and then I'm reading these two jumpers. So if I move this jumper, you can see we're now doing a little rainbow LED pattern. Take that off the ground. There we go. I've also got the danger, danger alert eyes there running. So run if you see the little lemon wedge get that angry. This is... nothing good can come of that. It is the Adafruit Flora V3. Yes, it is. What's some thoughts on the name for this little character? Think about it. He's so cute. Go over there and hang out. I have not checked to see. I didn't do anything to make that particularly efficient code on the LEDs. I think it's going to burn through that tiny LiPo on there pretty quickly, but we'll see. Keep an eye on those sparkly eyes right there. See how long he lasts. He or she. All right. Next up, let's do a CircuitPython Parsec. CircuitPython Parsec. All right, let's put that background away. There we go. I think you can see that pretty well right there. Yeah, so this is the, there we go. This is the continuation of our Mecha Trellis, Neo Trellis, Trellis stuff. So for the CircuitPython Parsec today, I wanted to show you how we can create a velocity meter on the Trellis device here using MIDI and MIDI note velocity inside of CircuitPython. So first of all, a demonstration. You can see here, I'm just going to play some notes on this little MIDI keyboard off to the side. Let me show that here. So I'm just playing some notes on here, and what you'll notice is, as I press the keys lightly, we just light up a few LEDs. As I press harder, we get more of the LEDs, kind of like a VU meter, but instead of measuring volume, audio volume, it's measuring how hard I press the key, the velocity. So a lot of MIDI keyboards have this velocity sensitivity. It's fairly simple in a lot of inexpensive keyboards like this. There's just two switches that get hit, and it checks the sort of time of flight between those two to decide how quickly you've hit the key. How much velocity you've used to hit the key. So the way this works inside of CircuitPython, if we take a look at my code here, is very similar to the previous code, except this time I'm using async I/O. And this means I'm able to have two sort of main chunks of code running back and forth without getting in each other's way. It's not, strictly speaking, parallel processing, but it does allow one read of all of those MIDI notes to kind of get out of the way and let a write to all of those NeoPixels happen and do it in an organized fashion. So that gets imported. The rest of this is all the same sort of MIDI, USB MIDI and Adafruit MIDI, as well as the Neo Trellis and multi-trellis. And then I have some user settings here for what velocity I want to map to what set of NeoPixels. So I have 8 NeoPixels here. Velocity can go from 0 to 127. And I am unlikely, on this keyboard at least, to press that any lighter than about a 20 or a 30. So I wanted to be able to capture that by having user adjustable velocity ranges. And then I also have some values here for how quickly those LEDs fade and how many steps of fade they have. The main functions that we're dealing with here, I have a velocity to height, and that's what says, okay, depending on how hard I hit it, how many NeoPixels are we going to light up. Drawing a column, just so we can call that when it's time. Setting up the display initially. And then here are my two async I/O tasks. I have, did I pass it? There we go. I have this MIDI task function, and I have this display task function, and those are made as async I/O functions. So in the first one, we receive a message, and from that, we check to see if it's a note on message and the velocity is greater than 0. If so, we run out and ask for that velocity to, sorry, let me turn off these Do I know how to turn off these diagnostics in this version? I don't. All right. Sorry, we're going to get some of these big code chunks in the way. So then we run off and say, okay, for this value that was pressed, how many of those pixels are we going to light up? We have that value stored, but we actually don't use that until the next async IO hands off to this display task. So we've just calculated how many neopixels, then this is where we actually draw them. So when we flip over to this task, we check and see the current time so that we can count down for that fade. And then we run either the fade or the light up using the number of neopixels for that column that were determined by the previous async IO function. And then the main loop here just runs the MIDI job, which is async create task MIDI task, and the display job, async create task display task. And then we await that async IO gather, which says, okay, it's time to move over to the other one, and then run it. So that's able to get out of the way and allow for, let me do a arpeggio. So there you can see it playing. I don't know if you can hear that too well. I can't remember if I'm piping that through. I think I am. Yeah, you should be hearing that regardless of my volume. All right, and so that is how you can meter the velocity of your MIDI keys using CircuitPython running on a trellis. And that is your CircuitPython Parsec. And you'll have to tell me in the chat, let me bring open my YouTube chat there, it hid out of the way. You'll have to tell me, sorry, I can't remember if I showed the tool that I found that makes it pretty easy to pipe one MIDI thing event into another device, all on USB, all on one computer. So I have this little MIDI keyboard plugged into USB, and then I have my feather that's on the running the Mecha Trellis set there, plugged into same computer over USB. Excuse me. And I'm just gonna add a window here so you can see this program appropriately enough called MIDI pipe. So let's go screen capture, new screen capture, and I'll point that at little old MIDI pipe here. This is something I could have used years ago. I don't know how long it's been out. I only recently discovered it, but it solves this this very situation really neatly. So what we have here are a whole bunch of tools on the left, and you can drag them over into a sort of pipeline on the right here, these pipes. And so you can see my first one here is MIDI in, and I told it, okay, read that Arturia key step 32. And then I have some things I don't need here. This is a little visualizer that is fun, but I don't need it. Then we have a list of messages to show. So if I want to just see those in my little window here, I'm filtering that down to just note on off. Then we have a message filter that kind of works in the opposite way. I'm turning off everything but note on off. And note on off includes velocity, so that's not a separate thing. If I were using polyphonic aftertouch or channel aftertouch, then you could get more fine-grained. This just shows me what's been filtered out. I was using that just during development. And then MIDI out. And really all we would need is MIDI in, MIDI out. But by filtering out some of those messages, I think we're probably saving some bandwidth on the CircuitPython read side. And so the MIDI out, we just pick another device. So I'm picking the Feather RP2040 here as my output device. And then lastly, the reason we hear anything, instead of me setting up a separate synthesizer like VCV Rack and also porting the MIDI to it, this actually has a nice little pipe that accesses the built-in sort of Rompler synthesizer that's built into Apple, into the operating system. So this has a whole ton of instruments that you can pick from in here. So Oh, let's see. What do I have to do to... I don't know what I have to do to tell it to actually use that. Or are they down here? Oh, I can't remember. Sorry. But that does allow you to access all... There's a few hundred, I think, built-in synthesizers in here. That's definitely not working. What did I do wrong? Who knows? But go check it out. This is called Subtle Soft MIDI Pipe. It's... donate as much as you want where. I'll give them some money. I've been using it here for a week or two, and I really like it. But yeah, go look it up. Subtle Soft MIDI Pipe. Very helpful. All right. Let me put that away so that I have some space here for some other things I want to show off. And that's actually right there. And I can move that out of the way now. The next thing I wanted to do, so let's talk about the really the only change I made here. I'll go to the down shooter over here. Let me bring up this. Yeah, let's bring up this view over here. So I'm gonna turn on this other mic. Hopefully that's a little better than last week. I was able to do some tuning of this. Thanks a lot to C. Grover in the chats for helping me test out some settings on the mic and come up with some EQ curves and things. I also moved the mic. This is a shotgun mic. It's actually now right here, like a boom mic should be. It's just right over my head. It was down there close to the air conditioner before, which is bad news. So let me get this out of the way. So this is our ESP32 based motion detector. You can see if I kind of stand still off here to the side a little bit, it does not notice any motion. As soon as I start to move a little bit, it detects that motion. So I'm writing the guide on this. This only thing I wanted to characterize here is the difference between the smaller antenna and the bigger antenna. These are, if you've ever been curious, these are the two different 2.4 gigahertz dipole antennas that we sell that are that fit this little adapter for the ESP32S3. So same threading, the thread's right onto there. One has, I think, 5 dB gain, and the other one might be like 2 something. I don't think I have the label for that there. So I'm going to try those out, see if there's any case where you might want to use one over the other. But that is the little case I put together for this. And if we unplug here, do I want to pop this open? Sure. This just pops open like this. Get a little closer to it. There we go. I broke my own rule here of not wanting to put parts on 2 halves of a case, because then we've got to tuck stuff away while we're closing it, but it's not too bad. It's just this one wire is quite long. I might see if I can find a good way to coil that before it goes in, but as long as you get that out of the way of these buttons here in the screen, that snaps into place pretty nicely there. And this, since I screwed the little guy onto the case there, a little adapter, we can then thread an antenna onto there. These antennas are really nice. Once you get that screwed on with this little knurled grip here, you can hold that part and it still swivels, so we're not unscrewing it by turning it to find the right angle. Oh, looks like I missed the snap fit there. There we go. So, oh, I got this. Yeah, I got the wire in the way. One more try. This is a little design I made just as a modification to the Feather battery monitor project that I think Pedro had built originally. So you could keep that original design and just add the support and hole for the antenna there, and then run a battery out the back here if you want. I think I'm not snap fitting anymore. I might have my wire in the way. But there you go. So let that boot up, and there we go. Connects to Wi-Fi. I have a little router behind me for this. I'm going to try to stand still while it calibrates. And if I move, motion, 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 motion. Pretty cool. So I just put the code base for that up in Adafruit GitHub, and I'll be putting the guide for that together. So that's the update on that little project, and let's see. Oh, that's a good question. C. Grover says, can the proximity detection provide variable values for a theremin synth.io instrument? Yeah, it's a really good question. It would be nice to graph some of this. Is using a whole bunch of different channels at once to develop its characterize the noise that you're generating by moving. But it's a good question if any of that would be useful as proximity, or if it's just too crude. Not sure. Good question. All right, so speaking of wireless things, oh no, wait, before I do that, do that in a minute. Let's talk about this thing. So why is the coupon code today computer? Because I'm very excited about a new Eurorack module, also called computer, not spelled that way, sorry, confusingly. I chose a different spelling just because that seemed more fun. Let me go to my browser here. Let's pull up this. Okay, let's talk about this thing first of all. So what I'm showing here, this is a simulated virtual version of the Music Thing Modular. Try to make it fit a little better here. Let's see. There we go. The Music Thing Modular workshop system is a, get this to fit, there we go, is a physical real-world synthesizer that combines a whole bunch of very useful small modules that you might typically buy as one-off pieces in a modular synthesizer system, combines them all under one roof in a Pelican case about that big, and they are I think they're all standard Eurorack size. You could probably mount this in a Eurorack, pretty sure about that. But this is meant to run off of USB-C, so you can use a power bank or a wall adapter if you want. And it gives you sort of a somewhat mirrored top to bottom set of dual modules. So as you can see here, this sine square oscillators, there's one on the top, one on the bottom, a pair of the inputs and the outputs, a pair of the inputs and the outputs. Some of these don't mirror. There's a ring mod right in the middle. There's a little stomp box adapter on the bottom, stereo input, but then we have, again, the humpback filters are two filters sort of in one module. And this is very neat. This is at vincentmaurer.de. vincentmaurer.de. I'll put that over in the chat on Discord if anyone's interested. This is a simulator, so you could check it out, see if you like it, if you actually want to get a kit or a finished version of this to play around with. However, I think one of the more interesting things to me is on the far left here is this module called Computer. And this is an RP2040 or 2350, sorry, I can't remember. It might be 2350 based brain that can be programmed to kind of do whatever you want with a set of control voltage inputs and outputs and audio inputs and outputs, similar to the Winterbloom, oh gosh, what was its name? There was a Winterbloom module that's a similar idea of using a little computer brain that can do other stuff. Ornament and Crime is another really well-known one. This one, I think one of the more interesting things about it, however, is if you see that little thing at the bottom that says card, it's a little memory card that's not an SD card to reduce confusion. It's just a small PCB with like 8 little fingers on it to plug in and be read by a little reader, and it contains a essentially your RAM for the RP2040 inside. So what program gets run is based on whatever's on that card. So you can write code in CircuitPython, I think Arduino, Lua, a whole bunch of different languages, and access all of these inputs and outputs and the potentiometers up there, switches up there, to then process data, process audio, process control voltage. So the interesting thing is I already have a lot of Eurorack modules, and I was really hoping that Tom Whitwell, the creator of this, was going to come out with a standalone module, and today he announced the standalone module. So this thing right here, Music Thing Modular Workshop Computer, it's a DIY kit where most of the thing is surface mount soldered, that's already been done for you. I don't know if there's a good picture of it, but there's a how-to guide, and it looks like you're mostly just going to screw on or solder on LEDs, potentiometers, jacks, that kind of stuff, and put it together. So it looks like a fairly simple build, but this is, I ordered one because I want to put it together and I want to see what interesting things can be done with a sort of bespoke ADC DAC type of hardware that's tuned towards Eurorack voltages and can accept CircuitPython. So I'll know more once I get it and play around with it. I haven't paid enough attention to it, honestly. Sorry about that, Tom. But I think, let me see, I feel like there's a, yeah, here we go. So it can be programmed in C, C++ with the Pico SDK. It is an RP2040. Arduino, Pico, CircuitPython, Lua, anything that runs on a RP2040 essentially. And then you can share the code either online, or you can make those little cards. They sell blanks and sell them or give them to people. There's at least one manufacturer out there, RYK, that's selling reverbs and delays and other processing. In fact, this is kind of the most interesting part, I think, is the let's see, GitHub PGM card library. So these are all different programs that you can make that thing do just by plugging in that little card and starting it up. So there's a simple MIDI for reading MIDI on that device. There's a Turing machine, which is one of Tom's original sort of Eurorack classic that develops, using a shift register, develops melodies. The BYO Benjamin chord, USB audio and MIDI, bumpers, Goldfish, which I think is a little weird delay looper that is very forgetful, very short delay looper. Let's see what else. Resonators, reverbs, Sheep, I think is a granulator, pitch shifting granulator, and on and on. So these are all ones that you could download, put on a card, and run, and tells you what they were developed in, and usually sends you to the repo. So this is really exciting as a sort of ecosystem, I think, for developing things. And of course, if you were feeling creative about it, you could probably use this for things well outside of Eurorack and synthesis, just as a piece of hardware that you can write code for on little cards that processes voltages in various ways and audio in various ways. So that is how we came up with computer today as the coupon code. So go check that out. Again, I'm not paid to do this. I didn't get one for free. I just paid my own money to order one. But Tom does awesome stuff, and if you want to go take a look at that, and there are links in there to videos. There's also a very active Discord community for people developing, building the workshop system itself, and now there's a channel, dedicated channel just for this one module, the workshop computer. So that's my spiel on that, and hopefully I'll get that soon. It's shipping from the UK. Thonk is awesome. They do take care of duties and taxes and things, so you won't get hit with a surprise bill in the US if you order from them. So I've bought from them for a number of years. I think they're fantastic, so I feel good recommending that. Go check it out. All right, and next up, let's talk about this upcoming project. So I'm going to grab this. First of all, let me find, let's go to a down shooter and that face cam. Let me get the pieces parts here. So let me get a lot closer because these things are small. I've decided this camera likes light. Not surprisingly. It has trouble in low light. So there is a little cutie pie ESP. And here is a NeoKey BFF and a mechanical key switch, a little Cherry MX mechanical key switch. And then here is a little LiPo power BFF. Also got a little tiny LiPo battery there with its little JST plug. So what I wanted to do is put together our own version of a Bluetooth single key macro pad or remote or keypad that can be small, fidget toy sized, little fidget clicker sized. I went with this nice clicky kale white key switch here. And the ESP32 cutie pie here is the Pico, I think this is called a Pico V3 module, but it's kind of the original ESP32. So it has fantastic support for different types of Bluetooth and BLE. So I'm starting out with BLE, but I might also be able to do Bluetooth Classic on it if there are convenient libraries to use for that. So this will be developed in Arduino. This is not a board we use with CircuitPython at all, I think, generally. I can't remember. I'm sure someone has somehow managed to get CircuitPython on here, but I'll be doing this in Arduino. And the idea is just to have a little bundle with a USB-C port exposed for charging and an on-off switch. Turn it on, use it to send little single key messages or macros. Could be a mute button, a pause button, that kind of thing. And also probably I'll do some deep sleep stuff so that it won't waste battery if you forget to flip it off. Since we've got a RGB LED both on the top of the cutie pie and uplit underneath the key there, we'll be able to do some little LED indicator stuff. And I may also look into some single key combo things to change modes, like can you triple click a certain pattern that just changes it to a new mode. That can get kind of out of hand, but I want to try it anyway. Sorry, I'm just gonna move this camera up a little so you can see the construction here. I do have a demo of this working, but before I do that, I wanted to show you something I came up with for prototyping this. And the reason is, with our BFF, best friend forever types of boards, what you'll see is they say USB solder back to back. So the real sweet spot for these is if you just wanted to LiPo power your cutie pie, then you would just solder header pin to one, push the other through, solder header pins, and now we've got a neat little package for adding battery power to this. Same with the keyboard. We would need to plug this in like this because that's the direction things match. What this means is they're a bit annoying to put on a breadboard because they're backward, upside down of each other. You sort of have to set them this way and then run wires across because left is right and right is left. And it's not the worst thing in the world so long as I made a little fritzing diagram so I wouldn't confuse myself, put it together, put it on a breadboard, wired it up, and my code was not working. And I was going a little bit bonkers for a while there until I wired some things sort of directly, bypassing parts of the breadboard, and realized I just had a faulty breadboard. I had a loose connection in one critical pin, and I threw it in the trash. I know we sell like replacement metal strips, but I was so annoyed with the thing, I threw it in the trash, and I came up with this, which is 2 of our long stacky headers. I think these come in 6. We have them that are 6 wide and longer. So I cut them down to 5. No, 1, 2, 3, 4, 5, 6, 7. They come in 8, and I cut it down to 2, 3, 4, 5, 6, 7. Yeah, cut it down to 7. Is that how many pins these have? Must be. I put 2 of them together. I tinned their ends. I soldered them together, and so now I have a female to female adapter board for putting 2 of these BFF and CircuitPy things together at a time. Obviously, it's not going to help you if you've got 3, except for a weird hack I'll show you. But that right there, there's no reason for that to be that huge, but that was easier to solder than standard female header pins. But if I put that together like that, you can see USB there, USB there. In fact, let's plug that in. Let me just double check everything. You're all USB to USB? Yes. So you can see it powered on, and I've got LEDs on both sides. So this is a nice way, just during development primarily, unless you had a reason to keep that for your project, but it's a fairly lightweight way without having to make a custom PCB or anything like that to put together a couple of these. Now, I will show you the terrible idea that dawned on me with this, and I'm not going to fire it up just because it's a little risky right now, and I got to show a demo, but you probably see it coming. So this thing here, USB side up, USB side back to back, this will fit with its little castellated pads right up against these exposed contacts here, these legs, and it's a little easier if you remove one side. Wedge that in. Spring tension holds the little castellated pads in there, and then put this back on, USB to USB side. I did test it. There's an on-off switch on there. I plugged in the LiPo, and I can in fact power that up from there. Maybe I'll do it at the end of the show, but right now I'll leave that. So that's my really terrible idea for, and I think the battery even kind of fits in there. So you can make a tall, weird thing this way. So that's what I came up with just for this prototyping stage. The other interesting idea I think could be worth exploring is doing, since we have the castellated pads, doing stuff sort of edge to edge, depending on what you're putting together. Doing little edge to edge stuff could be possible, but not necessarily practical. So with that, let me put this, just the key switch, BFF, and the CircuitPy back together. And again, USB to USB side. So this little CircuitPy BFF, it just uses power and ground because of the NeoPixel. It has pin A2 for the switch and pin A3 for the NeoPixel. So I set all that up in code. I'll put the actual key switch on here. And I'm going to fire this up. Off it goes. That it turned green because it connected to Bluetooth. So I have a laptop over here. Let me see if there's a good way to show this. Right here. Let me move this over to the workbench in a second, but let me just log into this laptop and see if we can see this. go to actually just a full view here. And sure, okay. So we got all these capture devices, and this is how I'm going to share the screen. But all you're going to look for is a letter getting pressed here. So you can see, click, click, click. Each time I click this, I'm just getting a letter Z to type in there. I'm also, you can see, changing the color when I press it. So that shows up as, what am I doing here? A, capital A. It shows up as just capital A's when I press that. If I, let's go, let me show a small down shooter view. Do I have such a thing? No, I currently don't. Okay, let's go to the big down shooter view and back up here so you can see a little green glow there of the LEDs. If I come over here and just disconnect that device, I think I'll just turn off Bluetooth. I say that like I can do that. There we go. Bluetooth. All right, so you should see that go to red right there, just because I turned off Bluetooth. I think it's persistent enough that when I turn this on, this should, the next time I press the button, try to connect. So this is set up. Oh, it did it on its own. Okay, I thought it needed to wait, but that was, I think, a previous version. So that'll connect there. So I'll put this over here for a second, and let's take a look at what's running on here. I'm just going to open that Arduino code in Z because I don't think I have Arduino set up on this new computer. So let's go to IDE view. And I'm going to look for oh, I think I'm not. Okay, let me grab that. I was not syncing to that folder. Hold on one moment. Okay. This. That. Okay. That should sync pretty quickly. Just give that a minute. Okay. One key. I think it's this one. Okay, yeah. So this is using a library called BLE Keyboard. And then NeoPixel. So it's fairly straightforward. Hey, Thin Man said it should be a blue light for Bluetooth, not green. I think you're right. I can't remember why I had that set to green, but thank you. Yeah, Bluetooth is usually blue, right? So I've got a Bluetooth device name. So when I instantiate the Bluetooth keyboard, it'll show up as that, so I know what I'm picking on the computer. I've got a user variable here for the key to send, which right now I'm just using an A. The pins that I'm using, and some variables for brightness and debounce. Set up the two NeoPixels that I've got on the one on the board is called pin NeoPixel, and then this other one is the A3 pin here, just with a variable name. So I set my pixels up. In the main setup loop here, I set the NeoPixel power to on. The ESP32 Cutie Pie, I think this was a Lamore design just to help with power savings. You can disable the NeoPixel pin entirely if you're trying to go for a low power mode. So you have to actually toggle that NeoPixel power pin on to use the NeoPixel, or turn it off if you're trying to save battery life. So I set those NeoPixels on, and then I have this button pin, which is an input pull-up resistor pin. The main loop here is if the BLE keyboard is connected. By the way, I set this up, and during setup I turn on the actual BLE keyboard. So the main loop, if the BLE keyboard is connected, then we set the pixel to green here. I'll change that to blue. If the digital read on button pin is low, that means I've pressed it, 'cause it's pull up, so it goes low when it's pressed. Then I'm setting it to pink, and I'm doing a BLE keyboard print, whatever that key to send is. And there's a few different ways, commands there for send versus print, and a couple of others, but this one works well for this case. I think you have to use the other methods if you're doing like Control Shift Z or whatever key combo you're doing. But with print, you can just send a single key. A little delay to deal with repeats right now, just very, very simple, crude version. And then I set the pixel back to green. Otherwise, if we're not connected, if that's false, then the pixel is set to red, and then I just have a little small delay in there. So this is the very bare bones version. I had started with some more elaborate stuff and was just running into problems both with the breadboard and connecting to an iOS device, which is for some reason, way more complicated here than I think it needs to be, but I'll work on that. But for now, the easiest connection I had was actually with that Windows laptop using this little guy who's probably over there typing AAA again. So this will get a lot smaller when I remove the temporary female extra monster headers there that I'm using. I'll get it down pretty small and build a little 3D printed case for it. This, by the way, was inspired by let me find the link, a existing Kickstarter, and I'm not sure if this Kickstarter happened, like went all the way to fulfillment phase or not. I didn't look very closely, but Lamore, I think, found this, or Phil found this and sent it to me. Let's bring that up just so you can see the inspiration. And there it is. Mono key. Okay. So this here, mono key, was the really cute, and I think it's an ESP32 based thing. It's got a USB-C port there. It looks like an injection molded case, which is lovely, and not terrible price either. At this point, I guess $39 might be if you can still buy that. So it is a hot swappable key switch, like on here. Put your own little keycap. They got a nice design there. Mine will have to be a little bigger just because of the sort of off-the-shelf parts and battery that I'm using. But you can see there, if you do get that connected up to your phone, you can do things like shutter release. That is a really good use for this kind of thing. Keyboard combos, media playback, pause play, can use HID, consumer control over Bluetooth, those sorts of things. So that was the inspiration, but I've got the parts here. I might as well build an open source version of that you can build yourself and customize. So let's see, anything else? I think that's it. Let me just check the chats there. I think we're good. So just a reminder before I go, the coupon code today, if you want to go buy some stuff in the Adafruit shop, is computer. Go buy some things. That'll be good until midnight tonight, and then it goes away. So thank you to the Discord for coming up with the Prime memes, like the big red shiny button. Ren and Stimpy will always make me laugh. Thanks there, some nice. All right, that is going to do it for today. Thanks everyone for stopping by. I think Scott is doing a deep dive tomorrow. I think that Foamy Guy is on to Tuesday mornings now is the new time, but he's possibly doing over the weekend as well. Also check our blog for info if there are any Desk of Lady Ada or Ion NPI or other new product videos that we're working on last night. Should be out. I'll be back on Tuesday with another product pick of the week, and Wednesday morning there will be a 3D hangout, and a show and tell that evening. So please come on by again and again and again. Otherwise, we'll miss you. Thank you, everyone, so much for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye. Hey, look, his eyes are still glowing. Let's make him angry. Weep, 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 weep. Don't fall.